Okay, welcome back. I hope you had a good break. Welcome back to Montgomery County Master Gardener's class on rainwater harvesting. This is part two. You should have just finished part one. Now, before we actually get back to part two, what I'm going to do is bring up the shared screen showing what you should have as handouts. And so you should have a handout of at least four pages, either double-sided or single-sided. But and let me just basically what this is our summary of our projects at the extension in rainwater harvesting. Here's a map showing our project locations. This is a summary of rainwater harvesting in general, just basic bullet points. And this is the information on the key publications and what key websites for rainwater harvesting that could be helpful for you. And this is the detail that I wanted to show you specifically. This shows the detail on what parts are used in making the self-cleaning rainwater harvesting barrel. Adding this section here, this cross piece and this vertical section. That's not very much, but it can really save you a lot of work later on. And then we have a couple more examples. Okay, so that's what I wanted to show you. That should be either as a handout or it should be on a flash drive to you. So now we're going to back to our shared screen, other shared screen. Okay, part one, let's go to, okay, we finished part one of general information, passive rainwater harvesting and active. Now we're moving on into the uses of rainwater, components, and maintenance. Flowers and trees, that's a good use for rainwater. That everybody likes that. Everybody knows that. For vegetables, of course, fruit and vegetables, it's great. For ponds and fountains, not everybody thinks of ponds and fountains, but they are an excellent use for this. Fish and birds and insects really enjoy it. It doesn't matter what impurities might be in it, as long as, just from, I'm talking about bacteria from bird droppings or leaves or branches or whatever might be there. So it's perfectly fine for them. Wildlife watering stations, that's one of the things we use them for, and here's one set up. The water actually is dispensed through a long line. It's just dripping into this little bird bath slowly, maybe one drip every couple seconds or every 15 seconds, depending on how fast the evaporation rate is. And there's no pump needed for this. You just have a little valve here and you turn it on and gravity will pull water down. Either crank it open and you can get a full stream, or you can restrict it down to just a few drops. That's perfectly fine. Here's one for the bees, and also used for squirrels, rabbits, deer, whatever might be in the area. Could use it as well. We also use it for aquaponics projects, excellent for tilapia, and water replacement for the plants that are using it. What about in the house? Well, think about what happens when rain hits the roof of your house. It's picking up a lot of impurities from, among other things, bird droppings. And that's not something you really want to bring into a glass of water and have in your kitchen. So we don't recommend that. Most of us are paying for municipal water, or we have wells which have a filtration system and a sanitizing system set up for it. So that's what you want to stay with. Use this water that you're collecting for your irrigation or for your gardens. If you do want to look further into setting up a filtration and a sanitizing system, you can go to the Texas Manual on Rainwater Harvesting. Remember I mentioned that earlier? The third edition. This is an example of a photo from there. They go into that into some detail, and that can help you decide if that's something you want to deal with, but that's not what we're recommending for this class. What about for lawns? Well, a 2,000 square foot roof would collect about 1,000 gallons per week in Conroe, because we have an average rainfall of about 1 inch per week. This is enough water, coincidentally enough, for a 2,000 square foot lawn. So you're putting money and your expertise and your maintenance into collecting special water that can be used for very beneficially for your plants or your ponds. The benefit here is that municipal water, as part of its sanitizing process, has a lot of chlorine in it, and that's going to hurt some of the wildlife wildlife, if not stunt their growth, to slow them down. They're not going to be they're not going to thrive as well as they would without it. So we recommend use your quality rainwater for your special items and use your municipal water, which is already set up for landscape, because it has chlorine in it, and most of your grasses are very tolerant to chlorine. There are a lot of fish and a lot of wildlife that aren't tolerant of chlorine. Lawn sprinklers also lose a lot of valuable water, which you'll hear more when you go through the the drip irrigation training. Evaporation, overspray, runoff, mechanical problems like broken sprinkler heads and so forth. So you just want to avoid that. Save your rainwater for your good plants. Benefits: one, it reduces or eliminates wasted water. There's no runoff, little evaporation. There's no water lost on sidewalks or oversprays. Better plant health because the water is applied directly to the roots at the soil level, and it's better able to meet the plant's needs and reduce diseases. With less runoff, your fertilizers and pesticides that you distribute around your plants will stay where they're needed. And if you're using brackish water for a watering source, drip irrigation reduces leaf damage by not wetting them. Something a lot of people don't think about, you'll have lower home maintenance costs since the water, or efforts I should say, since the water is not spraying the house or the fence, patching and painting is reduced. How many of you have walked or driven past houses where they've got, or fences where they have you can see that a lawn sprayer is typically sprays that fence siding or the house siding, and it's become bleached out, it's discolored. Well, that's what happens, and you're gonna have to treat that or paint it. So by doing that, by going to drip irrigation, you don't have to worry about that, or reduced. You don't have to worry as much about it. And windows aren't sprayed, so the less cleaning of the windows is needed. So your spouse will be happy as well. So components. We're going to talk about, for active rainwater harvesting, the collection systems, water cleanup at inlets and overflows, dry and wet systems, and water storage. This is actually a part of a housing project that's up in Montana. It's up in Austin, Texas. And it's where we had the ARCSA meeting and training in 2010. It's quite impressive. This is an energy efficient house. They have a 2,000-gallon rainwater collection tank here that provides water not only for drip irrigation, but also for flushing the commodes. I like this photograph. This is a picture looking out across some of the subdivisions or the hills of Berkeley, California. And I liked it because it had a lot of examples of different roof types. You've got tile roof here and here. You've got a wood roof, shake shingle here, and it looks like some sort of composite roof there. Flat rooftops, steep rooftops. This is a shale or a slate rooftop. A very steep rooftop here. Another flat but sloping rooftop, and so forth. And those, depending on the rooftop you have, you might want to consider what you're going to use your water for. The best rooftop for collecting water is a metal standing seam rooftop. It's nice because the dust and debris that falls on here usually gets blown off. And this is a fairly steep roof. And for that reason, we wanted to design this so that it would not only collect water, but also would stay clean. And it also means that you may have more dust and dirt that's blowing into these gutters here. And this is a first flush diverter. This is a screen. And then we have also a self-cleaning overflow valve in here, or line set up inside, which we're going to go over in a minute. But we'll cover those in just a few minutes. But anyway, so we've got 4 tanks, 2,000 gallons each, 8,000 gallon storage. This rooftop is about 10,000 square feet. So if you have a 1-inch rainfall, you're going to collect about 6,000 gallons of water. That's enough to fill these tanks 3/4 full, each tank 3/4 full with a 1-inch rain. Now remember, we get 48 times that during the year. So that's quite a bit of rain that's coming off this roof that you can do something with. We already talked about this, cleaning of dirt and dust. The runoff coefficient is the highest of the roofing materials, about 95%. Very effective. Asphalt shingles, composition shingles, are most common in our area. Again, we have these on a steep roof, which helps quite a bit. Even though they're very rough, they will absorb and they will trap moisture. So you're going to lose some of that. Their efficiency is not as good as the standing seam, but it's still quite good. And you don't have to worry so much about contamination because it doesn't stay on the roof very long. With a steep angle, it just shed right away. And there's not much dirt that this picks up either because it is fairly steep. Runoff coefficient is 90%, 85%. Concrete tile, it's suitable for a variety of different systems, but because it's a porous surface, you need to seal it or have it sealed. The runoff coefficient is 85 to 90%. Flat rooftops, water runs off, as you might expect, very slowly. It collects a lot of dust and dirt and windblown debris, so it takes a long time to clean it. In fact, I don't know that you really can clean it. You're just going to have to figure out a way to clean it up once it gets in the tank. And there are ways we're going to talk about on doing that. I would say a concern that you might have with this is if you have a drain, like a ceiling drain that drains it off the roof, if you do have a lot of debris, watch out with a big windstorm because it could blow, these plastic bags you get your groceries in. Those float and fly around quite easily in a good windstorm. And you could get a couple of these up on your roof and they could end up plugging up whatever those drains may be or where they might be. And as a result of that, this would fill up with water. This flat roof would fill up with water, which could increase it considerably as far as the weight goes, causing some structural damage. So be careful. Steep rooftops, just the opposite. Water sheds quickly, and it also gets rid of the dust, dirt, and windblown debris easily. First flush rain easily cleans it. Less time for water to absorb chemicals from the roof materials. Green tile or green rooftops, you don't hear much about them here. You're hearing more about them in large cities and back east, like in Washington, D.C. Also, they're very common in Europe. In fact, many cities in Europe will not allow you to, will not give you a permit to build this unless you have flat rooftops, that is, unless you have it set up for a green application. So it reduces lower temperatures, it produces lower temperatures on top and in the building, thus runoff during rainstorms. Good sound insulator, keeps the external noise low, reduces dust and particulates from the air, increases amenity spaces for displaying, growing, and possible recreation. So in summary, metal is good for rainwater harvesting. Asphalt roofs are good for irrigation and ponds. Tile and cement should be sealed. Steep roofs, water moves quickly, sheds dirt and dust easily. Low absorption of chemicals from rooftops. Flat roofs, water moves slowly, difficult for the first flush to do anything. You might want to think about cleaning up after it gets into the tank. Otherwise, you may lose too much water. Older roofs, watch out for lead contaminants from the flashing. That's something we didn't talk about, but flashing basically in the old days was actually made of lead. And they liked that because they could put it around the stack pipes that come up through the roof, and they would be able to just tap those into place and shape them very easily. And it made for a watertight seal. The problem is, of course, they're lead. Now, a little bit won't hurt anything, but you want to try to minimize it in most cases. Green rooftops, not good for storing water, but it is good for directing water into garden areas like a passive rainwater harvesting system. Gutters and downspouts, they should be smooth, durable, attractive, the correct size and slope. Now, we're not going to go through the details on how to set these up or how you connect them or what size is appropriate. There's so much out there online. And you can always go to Texas A&M on their website for rainwater harvesting. They talk about conveyance and sizing of the gutters. In addition to that, you can go to, you can also go to the Harvest H2O, look those up. There's a lot of information out there for that. Gutters and downspouts frequently, well, not commonly, but they may require that you do some innovative fitting. For example, here we have a rectangular downspout going into a rectangular, somewhat, but not the same size, rectangular collector that goes into a round delivery line. And so you have to do some sheet metal shears, do some trimming and cutting, and maybe some riveting, and then some caulking to seal everything up. Components, active rainwater harvesting systems. We've gone through the roofing, gutters, and downspouts. Now we're going into water cleanup at inlets and overflows. This is particularly important because we want to keep that water as clean as possible and so that it does the most good. So first flush diverter, we mentioned this earlier, right here. There's a plus a self-cleaning overflow, which is inside the tank. And this is a leaf and insect screen that's right up here at the top. So the water comes off, goes in. The debris, coarse debris, is rolling off the screen onto the ground around this structure, around this feature. And then we have down here, and then we have the water that goes through the screen just drops down into this first flush collector. By the time this fills, the water coming off the roof has cleaned up considerably, and now it's being diverted into the tank. Once it's in the tank, the water will tend to settle. Any particulates that might be in there that have gotten through the screens in the first flush will then settle down in the bottom of the tank. And that's where we have a self-cleaning overflow screen that will take care of that, which we'll show you the details of in just a minute. But let me show you that this is the last tank before we go to the pump. And we had to do one of the connections came loose, so we had to go back in and take care of that. And so we were really curious after 5 years just what this looked like. What we found was that there was less than 1/8 inch of sediment in the bottom of that tank. In 5 years, that's really good. We're not going to have to clean this area much at all, at least certainly not while I'm still alive, I don't think. This is a close-up of that first flush diverter and leaf insect screen. Here's the downspout coming off the roof. Here's the screen is up in this panel right here, and then it drops down into this collector for the first flush of water coming off. This is a commercial. Last one was a homemade one. This is a commercial one. You can buy this. You can order it online. It's very simple, very easy to get to, and very easy to install. Just make sure your pipe fittings that come with this system are American versions, so you don't have to do some adaptation to mix between two different size tubings. General rule, 10 gallons per 1,000 square feet of collection area. It depends on how clean the roof area is between rain events, which means how steep the slope is and the type of material it's made out of. For more information, you go to the Texas Rainwater Harvesting Manual, 3rd edition. There's quite a bit of information in there about that. Now, the simple overflow is, as you might expect, water comes in and is delivered into the full tank, or into the tank. And usually they have a take point that's about 6 inches above the base, and it'll collect debris and dirt and gunk down in here, and the water gets stagnant. But that's okay because you're not using it. However, at some point, it's going to build up over the surfaces of your take point where you're using it to bring it out of the tank, or out of the barrel, and over your section here. So what you want to do is try to keep this as clean as you can. This is normally what happens. Water fills up, and then it just flows out from the top on out. Now, what you can do is you can look at adding a section to this, a little section right here. It doesn't take much. And basically what's going to happen is, follow me on this. You're going to have water going into the tank, and it's going to fill up. These are openings down here at the bottom of this. It's going to fill the tank up, and as it fills the tank, it's also going to fill up the inside of this line. So as this tank fills up, this line fills up, and as the tank gets fully up to this level where we call spill point, water is going to start, as this tries to go up higher, it's going to push further water in, and it's going to try to go up here, but it can't because it's going to spill out, literally spill out. And it will start flowing down here. And as that happens, it lowers the pressure, and you get more water in. So where's that water come from? It comes off the bottom of the tank. So you'll end up cleaning up whatever debris or whatever small material is down here, because remember, you've already gone through a filter and a first flush diverter. So you don't have much in here to begin with. And this way, you'll have even less. So it moves it up and out. Make sure you have an opening at the top here. Otherwise, you're going to start a siphon process that'll drain your tank. You don't want to do that, not at this stage. So we set this up and run this. And you can do this with rain barrels as well, just a smaller scale. And here's a rain barrel at home, at my house. And this is in April or March. And you typically get these pods of pollen that open up and release pollen that's all over the place, literally all over the place, on our cars and driveways and everything else. Now this catches the pollen pods, but it doesn't catch the pollen. The pollen will float after you clean this off. After I clean this off, this is what it looks like underneath. You can see the yellow pollen sitting on top. And as this becomes waterlogged, it's going to sink to the bottom, and it will, as this water heats up, as you get further into the warm spring, it will end up decomposing and really smelling bad. I know, because I had to clean this one. And it's at that point that I decided, let's adapt the large tanks for self-cleaning overflow to the small tanks, to the small rain barrels, and it works great. And this is one of them. This is our demo that we use for teaching. And all we've done here, this is basically what everybody else does. And this is what we started doing. We've added this little cross piece and a T at the top and opening at the bottom. And water comes in, as I already described to you once. I won't go through that again. But basically, it's very easy to follow and very easy to do, and you can visualize it. None of these are screwed together. They're just tapped in place because it's a very fine fit. And that way, also, if you need to do something, if you need to take something apart, you can get to it very easily. The top of this opening right here is big enough easily to get this material in and hook it up. It's not a problem. Here's an example of an overflow line set up. This diffuser line is set up coming off the overflow line of a rain barrel. Now, dry and wet storage systems. Their name kind of describes what happens here. This is a dry system. After the rain event, everything dries out because all the water is drained out into the tank or into the first flush diverter. Wet system, everything goes into a lower section of pipe to communicate with your tanks. And at some point after the rain event, you need to go out there and open it up to clean it or drain it, let it drain. And so that's why we show this as a wet system and this is a dry system. An example of that, another example, a diagram, you can see the water coming off the roof going down into the dry system. Here's the first flush diverter, so that initial flush of dirty water, and then the cleaner water goes into the tank, which is where you want it to go. And when it's not raining, everything dries out. Wet containment, wet connection is something like this, where the water comes in, goes underground or down low, and then back up into the tank. This is typically what happens with water. It will take a U-tube effect. In fact, they used this as a leveling process years ago when they're putting in the railroad to make sure that they had the right slope on their tracks or on their beds. Works very well. Let's see. The only problem is that if the water sits down here, it's going to get smelly and stinky, and it can end up with mosquitoes and other things. So you need a way to clean it out. You can dig a trench here or a hole and make a small cistern and a little opening here that you can then open and drain, clean out if you want to, but it works very well. Let's see, is there anything else on this? There was something else, I think. I think that's about it. This is an example of the wet system. The water is coming off the roof and going down, coming over here and up into the tank. And here is like a first flush diverter. You've got a little cap on the bottom here. And what they've done is they've unscrewed that cap or that clean out so that water will, when this is empty or when it's not raining, this will drain out through here. You can use this as a site for going in to clean out things if you find it's gotten too mucky in there. It works pretty well. You can use leaf screens on the gutters or come out as they come off the gutters to clean out the loose debris. You don't want to put leaves in your tank because it's really hard to get them out and it'll really smell bad. Okay, wet system conveyance. No trees over this roof, so it's pretty easy to stay clean. Again, you keep the underground pipes drained and keep the valve slightly open or closed, and then open up between each rain event. And be sure the drain opening is screened with a hinge cover to keep out the critters because they will get in there and they will look for mischief. Next, we're going into water storage. And here's a caution. Tanks are heavy. Water weighs about 8.3 pounds per gallon. Be sure they are stable and cannot be pulled over. Watch for erosion around the base. Lock or bolt tank access to keep out children and animals. Screen all openings to keep out mosquitoes and critters. Keep your neighbors happy and yourself happy too. Check water quality. If the bacteria level is too high, treat it per TCEQ's recommendations. TCEQ, Texas Commission on Environmental Quality, and we don't list what they recommend to do now because it may change. What you should do is go to the website and check out what their website is on that list of websites that we've added for additional information for you. Go to their website and find out what they recommend for the time you're doing that. And again, public water safety is paramount. Do not connect your system to public water. The risk for contamination is too high, and damage would be miserable. So if the water may be used for emergencies for drinking, like in a water shortage or something like that, be certain that the tanks are of food grade quality. And if recycled, be certain they carried only food products. Container types. Well, we've got polyurethane and polypropylene, anywhere from 100 to 5,000 gallons. Durable, lightweight. However, the black tanks will heat up in the summer, so make sure you keep them in the shade or put a cover, build a cover on them. You can have the cover provide water into the tank as well. Translucent tanks grow algae, so we don't recommend translucent tanks. Get something that's black. Polyethylene is a flexible plastic, whereas polypropylene is fairly rigid. Most of the plastic tanks you see today are polyethylene. Prefabricated metal tanks, up to 2,500 gallons generally. Lightweight, zinc dipped to reduce corrosion. And the interior is usually painted with a food grade paint, or you can get a liner that will go in there as well. This is here in Montgomery County. This is also Montgomery. This is the Lone Star Conservation District tanks that they have on display. They do an excellent job. We'll talk more about what they've got set up there as well. Corrugated steel, 200 to 10,000 gallons. These are big. You don't see them too much because they're pretty heavy and bulky to move around. They have additional cost because you have to assemble them. But if you're moving to install a rainwater tank, a fairly large one, in a fairly hard to access area, you can actually transport these up by mule if you want to, because these actually break apart or unbolt into separate sections, so you can unbolt them and then carry them up. Fiberglass tanks, 300 to 15,000 gallons. They're long-lasting and easy to repair and can be painted. Now a guide for determining water demand and supply. Again, go to that Agrilife Extension publication B6153, Rainwater Harvesting. It's also known as G-404. And it'll take you through the steps that you need to follow. The big thing to focus on are calculations for supply, demand, max storage, and supplemental water that you can determine, and balancing supplies and demand. And they talk about this as well. But this is the area that you're going to want to spend the most time on. So water collection, just like we do for rooftop determination, rainfall versus catchment area times 0.62, that conversion factor we talked about earlier, and the runoff coefficient. Water usage, its demand, is determined by ET, which is, stands for evapotranspiration, and basically it's how easily or readily water comes off the leaves of the plants you're using. Some plants need a lot of water for that reason. Other plants don't need it quite so much. So that's going to determine a lot on how much demand you'll have from your plants. Irrigated area, here's the conversion factor again. Notice it's the same, 0.62 gallons per square foot. And then the plant coefficient. And you can get this College Station or Houston, and then you can look at between the two of them. We're kind of in between. I don't think there's that much difference, and you can use either one or the other. I would probably use College Station as a closer point source of information, but you can do that. We talked about evapotranspiration, plant and coefficients. Plant water use, it represents the water needs of a plant. A low water plant has an evapotranspiration coefficient of 20%. So we're looking at 20% here, and 50% here, and 75%. Notice your grasses are the biggest users. So if you want to save water, if you want to conserve water, think about changing your landscape from mostly lawns, which can look nice, of course, to something that's more a landscape, plants, shrubs, things like that are low water use. Now you can actually go cactusy too, but here we've got too much water for a lot of cactus. So then compare the monthly collection versus demand to identify the makeup water we might need. Actually, most people will try to identify the tank size by determining what the 2 to 4 week available rainfall is, and then we'll install that size, or the size that will help with rainwater harvesting and also look good in their yard. You know, we have to keep your neighbors happy and your spouses happy. And so that's something that's a concern for everybody. So for our area, we get 4 inches of rain on average per month, or about 1 inch per, 4 inches of rain per month, 200 square feet, a roof area, 0.62 conversion, 80% efficiency. So we're looking at almost 4,000 gallons of water per month that we could collect. So a 2 to 4 foot capacity is approximately 2,000 to 4,000 gallons. So that's what you're going to look for. Is that, figure it out for your own area and then make that decision. Is it going to look good, or do you want to go bigger? Can you go bigger? That's up to you. Or we can calculate, and for that, use the rainwater harvesting manual that we talked about earlier from Texas A&M University. They have some details in there that you can go with, and there's the website for it. Now you can connect tanks multiply. We showed several examples of that for our extension office, but you have to be careful how you do that depending on what your objective is. In this case, the tanks are set up all the water comes in here, you get stuff settling out, the overflow goes in here, you get stuff settling out, overflow goes in here. Not much stuff left to settle out because it's all up here. So these top two tanks are actually, these first two tanks I should say, are actually part of the cleaning up process. And ultimately, you're only going to have one tank that's going to be useful for your application that you plan to use. So these are going to be things you're going to have to need to clean out at some point so you can plan ahead for that. Now, if you want to go ahead and set this up so that you're using all three tanks, you can set this up as we did for our education center, where we have the 4 2,000-gallon tanks communicating together. And this is basically how we set up. Each tank has its own first flush diverter and water collection source, or downspout. We also have them all communicating together, and we also, each of them has their own overflow. So the result is we can use all three tanks like this, as it's shown in this picture. We can use all three of those going to the pump and then wherever we want to send them. So this is a benefit, quite a big benefit over the other ones. Notice that the polyethylene tank here was added later. You can combine them. This is metal, this is polyethylene, not going to make any difference. It communicates with the original tank at the top and the bottom and has its own overflow. Why is the overflow important? Well, if you didn't have the overflow here, you didn't have this cross piece at the top here, water would come in and it would fill up eventually, but it would also have problems with pressuring up in the top of this, or in the dome of the tank. And when you produce water from this and it would try to drop it down, it would create a vacuum. And that moving in and out could cause collapse, or expansion could cause a burst. And those have happened. And we'll show an example of HEB where they tried that and it didn't work out so well. So that's why you want it to act as an air vent for flow as water enters or leaves the tank. Here's the HEB. I mentioned that earlier. They have two tanks of different sizes. That's perfectly fine because they have a snorkel or a pipe that comes up from inside the tank, and these snorkels are all the same height. And the nice thing about the properties of water is that even though you have a tank that's shorter, the water will go up here at the same rate it goes up in here. So it's not going to get ahead. It's not going to start flowing out of this before it flows out of here. It'll all be at the same time if they're all the same height. And so that works really well. So if you're mixing two different size tanks, this is a solution for making sure that you don't have complications with overflow prematurely. And more connecting tapes. This is one sample. Really this is a small connector between fiberglass tanks. This is a bigger one. This is at our extension office. Here are 4 2,000-gallon tanks and a 2-inch line for connecting them. This doesn't look very pretty, but it works really well. You've got a downspout, and then it communicates. Not much cleaning up is going on. It communicates between the rain barrels with these double hose bibs, and that works perfectly fine. Now, whether they're using this for a garden or a place for their dogs to get a drink of water, who knows? The Jack Russells look like they're having a good time out there. Now, what about this one? What do you think about this setup? Now, it is collecting, and you've got multiple barrels, and it's all one feeding into another, so you are increasing your storage area. But what do you think? Yes or no? No, of course not. Why? Because barrels are rusty. You don't know what chemicals had been in them previously that might be leached into the stored water, and it's not stable. So use new barrels or recycled barrels that have been used for food products. What about this one? A little bit different. This looks pretty presentable. It looks pretty new. And it'll probably be fine for the first couple months of use. But notice they have these 4x4 posts that go down into the ground. And this is up on stilts. In fact, the house is up. It's not on a slab or anything. The house is up on stilts too, or piers or something. And what's going to happen is the bottom of these 4x4 posts are going to start rotting in the depth, or insects are going to start eating them, or there might be an accident and somebody run into it with a tractor or a lawnmower or something. Anyway, at some point, this area is going to become stable. So if the poor homeowner or maintainer of these rain barrels comes out sometime and is walking around up here on this platform to look at how things are going, or maybe make some repairs or adjustments, he might just end up tipping this so that it's no longer it's beyond stable and becomes unstable and collapses. And that could be really dangerous because remember, each of these 55-gallon barrels weighs over 400 pounds. Not good. And to drop 4 or 5 feet would not be good. So that's not a good idea. We're going to go into maintenance. And the nice thing is this is a good picture we're using for a lot of these examples. We're going to cover these different areas. But anyway, what you want to do is you look for leaks, erosion, blockages, reduction in pressure, reduction in volume, color changes, smells, storage and pumps problems associated with, let me start this over again. Roof and gutters, conveyance, first flush diverter and overflow, storage and pumps, and preparation for a freeze. We're going to talk about that. Look for leaks, erosion, blockages, reduction in pressure, reduction in volume, color changes, and smells. If it smells bad, it's probably bad. So when to perform an inspection? Well, after large storms, anything that changes the water volume or pressure, take a look at it. Look for leaks. If you see water, it's just like when you approach your car, you don't consciously have a checklist of saying, okay, my windows look intact, my tires are all round, I'm in good shape. Or no scratches on the outside of the car that weren't there when I left it. The same thing for your rainwater system. As you get used to that, you should, as you approach it or you walk past it, you just unconsciously or subconsciously think, okay, everything looks good, I can keep on going. But if something catches your attention that doesn't look good, well, then you need to take care of it to make sure it doesn't get worse. Because it can either be expensive or it can be dangerous. So you want to look for leaks, changes in water color monthly, do it monthly or during winter preparation or spring preparation. Roofs and gutters, don't use an anti-fungus, anti-moss, or anything for cleaning. Let it be natural. Notice that this is got a lot of debris in this. This is actually a roof screen. Now this is a leaf screen that is plastic. And what happens with plastic is with the heat and the sun that we have here, it tends to weaken. And in this case, it's slumped down. It's made a trough. So it's a trough in a trough, and it's not doing a good job of shedding leaves. So you've got to go in there and remove this and replace these with a metal or enameled screen that's not going to bend or change with UV light. Also check for leaves in the gutters. If you don't have leaf screens, even if you have leaf screens, sometimes squirrels will get in there in an opening and they'll build a nest in there, particularly if you've been a drought time or it's hot summertime and you not have much rain at all. Bird's nest, squirrel nest, get those out of there. This will keep your collected water from clean and flowing smoothly. Wet system conveyance, no trees over this roof, so it's not too much of a problem. Keep the underground pipes drained, keep the valves slightly open between rain events to drain it, or open it up all the way to make sure it's clean. And drain opening is screened or with a hinge cover to keep out the critters. Here's examples you can look at. Dry system conveyance. We talked about this before. Make sure that everything is clean and operating. Here we've got you can see the water from after this last rain event is cleaning out and draining this. You might have to clean this tube because it is going to collect this dust and dirt. It's not going to drain out through this little hole. You'll have to make sure you've got a threaded cap on the bottom here. Take it out, let it flush, clean it, and then put it back together again. Downspouts, first flush diverter and overflow, clean out bugs, leaves, and other debris. This is that screen I was telling you about. Here's another type of screen. Same thing, just take those off, clean them off. Maybe you have to get a ladder or undo a top like they have on the right here. Now, a lot of these first flush diverters will have a second screen inside. And you can see it collects a bunch of gunk, and you have to clean that about once every couple months. That's not too bad. Just make sure you're not wearing good clothes when you unscrew this, because if it's blocked and you've got water stored up above it, it's going to splash out when you open it. Although you'll have some warning when you start loosening this and it starts to leak around it. You'll see that. And also check to make sure your overflow lines are sealed or covered and operating properly. Storage tank and pump, check your air valves. Basically, just go over it. Just check for erosion around keep weeds around it, away from it. Check the tank for cleaning every couple of years. Look inside. Storage and pump, maintain a log of weekly levels and rainfall until you're used to it, and then you have a pretty good feel for how it's going. Ensure limited tank access. Check for tank stability itself and so forth. Any indications of leakage, make sure you get out there and fix that. Are electrical connections good and weather sealed? Make sure you don't have any, you don't want to take a chance on, because we're dealing with a water system, make sure you don't have any chance of electrocution going on. Water, color, and odor, if it's unusual, if it's different from normal, check it out. If it smells bad and don't taste it, please. If it smells bad and looks bad, it's probably bad. And then check with the TCEQ recommendations for either a bacterial analysis or just clean it yourself. They have the recommendations on how to clean it. Now, these are the limitations for irrigation water. This is not even going into your house. Irrigation water is much less controlled than house water because they want to keep people healthy. So keep that in mind. We do have cold weather here. It can be a problem. And this was in Conroe in 2008. We live in the south edge of Conroe. And it can cause problems. You can shut off your lines. But even so, sometimes you get trapped. For example, here we thought we had it drained. We took this off and drained it all, but we still had water trapped here, and that was just enough to freeze and crack it. We're fortunate we didn't lose this valve, crack this valve as well. You can see the crack came on down here, but it still held okay. Cold weather protection, tanks are fine, but to protect the valves that are coming off the tanks, the outlet valves, cover the pump with an enclosure, such as this, to make sure and insulate it with tarps and work with that. Now, you'll notice we have these black bags. This is actually mulch. You can take a black trash bag, put dry mulch in it, seal it up, and just gently put those over your pipes that are in there. They'll be perfectly fine. It acts like an insulator because the dry air is right there. It won't transmit cold very easily. And then when spring comes around and you no longer have a frost or a freeze problem, you can take these out and put them around your plants. So you're not storing anything. You're not taking time up to store stuff. Fiberglass mats or bags of mulch, either way. That's perfectly fine. Shut off the pump and shut off and unplug the pump, and then drain the pump and lines. You want to make sure you don't trap water in any of these lines, because when it freezes, water expands and you can crack things. We don't want that to happen. So I started a small scale, bird baths, potted plants in and out of the house. And we've talked about and showed examples of these earlier, so I'm not going to go through this, but start small and then build up as you feel like it. You can, once you have your tank in place, you can decorate it. We talked a little bit about painting. You saw some examples of painting smaller barrels. These are big tanks, and they're doing a great job with them. Most of these you have to put a base coat on it so the paint won't flake off. A lot of these tanks are flexible, and as they expand and contract with the heat and with the volume of water going into them, it'll crack and the paint will flex off. So use the right kind of paint and use a base coat, and you should be fine. And again, that's it for it. I hope everybody's got something out of this. Again, if you have questions, write them down, give them to your class coordinator, and send them off to Kim Pierce at Montgomery County Extension, and she will see that we receive these. We'll get them back to you ASAP. Thank you very much for your attention, and I hope this is my first video that I've put together, and we hope it's worked well. Thank you very much.